So my name is Abhilash Ramachandran. I work at the Arkansas Center for Space and Planetary Science here at University of Arkansas. I'm a postdoctoral fellow. I work on planet Mars, mostly experimental simulations of brine stability or liquid water on Mars, and to studying the hydrocarbons on Mars as well. Yeah.
I'm Peter James Gann. I'm a PhD student in cell and molecular biology. So I specialize in producing plants that can actually survive stress here on Earth. So we do mutations using CRISPR-Cas9 in our lab.
So there are many like missions that has been to Mars, like a spacecraft that's orbiting Mars, and there are also rovers on the surface of Mars. So using that, we know what the composition is like. We have taken lots and lots of pictures. So based on that, we've analyzed what would be the composition there, and then using like that data, we try to replicate, like NASA, people try to replicate these kind of like soil for the studies.
Well, rice is a kind of grass, and you can see from the environment around you that actually grasses are very persistent. Like they can grow in wet soil, they can grow in dry soil. So I would say they are versatile in different environments. So when we decided on which crop we're going to use, then we thought of like, oh, we can do something like grass, and rice would be a very good option. And aside from that, rice also produces grains which could also easily be prepared. So when it's grown in an environment that is away from here, those people who are growing it out in Mars probably later could use it also as a source of food. So normally in a greenhouse, we use what we call like a potting mix. So it consists of soil, organic matter with all the nutrients that are actually favorable for growth of plants. So that was our positive control. And side by side, we also had the smart soil simulant that Abby has from his lab. And then we also tried combinations of the Mars soil simulant with the potting mix. So we had different proportions of that. So of course, in the potting mix with all the nutrients, organic matter, and all the microbiota that are present in there, we saw like very good growth. But when you compare it to the plants that were grown in pure Mars soil simulant, we saw that there was a problem in growth. So we call it stunting. And then aside from that, the roots were actually less dense, and they are actually longer in size compared to the one that was grown in potting mix. So the observation on the growth could indicate that nutrients may not be as available as that in the potting mix in Mars soil simulant. That's why they don't grow well and they become stunted. And as to the roots that we have observed, so what happens, Joe, is that when your nutrients are not available in your soil or in your media, what happens is like roots will grow longer and they will try to find like sources of nutrients.
There's no atmosphere on Mars, so as we have here on Earth, so it all protects us. So on Mars, that becomes a very big problem. So as Peter mentioned, so what we'll do is we will eventually, like that would be like sort of a goal of our project in the end. So we build sort of a habitat wherein we place our plants inside the habitat, providing the right temperature or right humidity and right lighting conditions, and then take that habitat and place it inside the Mars simulation chamber. So, and then subject it to the Mars conditions and see how the plants would perform. So basically, it's close to the conditions that would, like, that would mimic the conditions on Mars. So my aspiration to become a planetary scientist was from a very young age. I would say probably in my high school, probably around say 14, 15 years old, when I was 14, 15 years old. So that is when India launched its first mission to the moon. That's called Chandrayaan 1 in 2008. And I was in my school reading newspapers, and it was all over the news media. And I got so curious. Until then, I didn't know what about like much things about planetary science. So this got me so invested to read more and more and more about planetary science. And that is when I started to think, okay, this is what I want to become, this is what I want to explore.
When I got the scholarship to move here to the US, it's the Fulbright scholarship. I was actually very pushy to go into a lab that works on CRISPR-Cas9 because I was very hopeful that the only way I can improve that population without introducing another population is by way of doing gene editing. And that brings me here in Arkansas, where a lab is working in gene editing. And like the thing is, like they are working on plants, but I was like, well, plants or animals, it doesn't matter. DNA is DNA. So I think as long as I have the basic concept, I can try to understand it. And I'm very glad it's going so well. Yeah. And then here I was working for the Stresses on Earth. And then it's so good that I met Abby while I was having coffee at one time in the student union. And then we talked and then we shared what we do. And it's like, maybe there's something we can do together. And then, yeah, and it was perfect. Like we just decided to do an experiment together.
Yeah,
to collaborate.
interdisciplinary science.